Hello guys, welcome to my YouTube channel Olympiad. As hopefully you all will be fine. Today we are going to solve a very interesting radical equation which is given as 2x plus 5 square root of x is equal to 3. We have to find the value of x. From this we can see that it looks like a linear equation but actually it is a quadratic equation and there will be two roots for this equation and we will solve this with the help of two methods, and at the end we also verify the two roots of the given equation to conclude that which of the roots is valid and which is not valid. So let's start the method number one. In method one we assume that this square root of x is equal to k, that is k is equal to square root of x, or from this if we take square on both sides it means that k square is equal to x. Now putting these values of x and square root of x in this equation we will get 2 times k square plus 5 times k is equal to 3, and rearranging this 2k square plus 5k, taking this 3 towards left hand side we will get minus 3 is equal to 0. Now we can clearly see that it is a quadratic equation. As I said earlier in the start, it looks like a linear but actually it is a quadratic equation. So now we will factorize this to find the roots. To factorize, we have to find 2k square times minus 3, which will give minus 6k square. This is the product of the roots. So we have to find two terms which on adding gives us 5k and on multiplying gives us minus 6k square. So 2k square, this 5k can be written as plus 6k minus k minus 3 is equal to 0. So this is the right factor pair. On multiplying 6k times minus k we will get minus 6k square, and if we add 6k minus 1 we will get plus 5k. So this is the right factor pair. Now we can take 2k common from first two terms, and we will get, after taking 2k common, k plus 3, and we can take minus 1 common from these two terms and we will get k plus 3 also from here, which is equal to 0. Now k plus 3 is common factor, so taking k plus 3 common we will get, here we remain with 2k minus, from this we get 1 is equal to 0. Now from this we can find the roots as k plus 3 is equal to 0 or 2k minus 1 is equal to 0. Now from this the value of k is minus 3, and from this 2k is equal to 1 and the value of k is 1 over 2. Now as in the start we state that k is equal to square root of x, so with the help of back substitution we will find the values of x, that is k is equal to square root of x which is equal to minus 3, and from here square root of x is equal to 1 over 2. From this we can find the value of x by taking square on both sides like this. This square will be cancelled out with this and we will get x is equal to 1 over 4, which is the final root of the given equation. Now from this equation we conclude that on the left hand side there is a square root term, and it is equal to minus 3, which is not possible. From this we can conclude that it is not possible because any square root can never be equal to negative term. Square root can never be equal to negative term, so that's why it is not possible. Hence we left with the x is equal to 1 over 4 root, and now we will verify the validity of this root. For this purpose we will write the given equation, which is 2x plus 5 square root of x is equal to 3. Now putting the values of x, which is the 1 over 4, we will get 2 times 1 over 4 plus 5 square root of 1 over 4 is equal to 3. Now simplifying this, we will get this 2 will be cancelled with this 4 and we will get 1 over 2 from here plus 5 times 1 over 4 square root is equal to 1 over 2, which is equal to 3. So 1 over 2 plus 5 over 2 is equal to 3. And now taking LCM, we will get 2, 1 plus 5 is equal to 3 and 6 over 2 is equal to 3. From this, 3 is equal to 3. Hence, this root verify the given condition, given statement. So, we can see that x is equal to 1 over 4. This is the valid root, valid solution of the given equation. Now we will use method 2 to find the roots of this given equation. For this we will write the given equation again as. Now in method 2 we will take care to eliminate the square root. For this first we will rearrange the given equation as taking this 3 towards the right hand side, left hand side, we will get 2x minus 3, and taking this 5 square root of x towards right hand side, we will get minus 5 square root of x. Now taking square on both sides, we will get 2x minus 3 whole square is equal to minus 5 times square root of x whole square. Now we will open this square by using the formula a minus b whole square is equal to a square minus 2ab plus b square. So using this formula we will write this equation as 2x square minus 2 times 2x times 3 plus 3 square, which is equal to minus sign inside the square will become positive and 5 square is equal to 25 times, and this square will be cancelled out with this square root and we will get x from here. So now we will simplify this equation. 2x square is equal to 4x square minus this will become 12x plus 9 is equal to 25x. So again rearranging it, we will get 4x square minus 12x plus 9. Taking this 25x towards left hand side, we will get minus 25x and it equal to 0. Now again simplifying 4x square minus 12x minus 25x will become minus 37x plus 9 is equal to 0. Now again we will factorize by using the same method as we used earlier in the start. So the product of these two terms which having answer 36x square is 4x square. From this we can write it as minus 36x minus x plus 9 is equal to 0. So these are the two terms. If we multiply these two, we will get 36x square, the product of 9 times 4x square, which is equal to 36x square. On multiplying these two terms, we will get this, and if we add these two terms, we will get minus 37x. So this is the right uh, factor pair. Now we will take 4x common from these two, and we will get, after taking 4x common here, x minus 9, and we will take minus 1 common from these two and we will get x minus 9, which is equal to 0. And again taking x minus 9 common, we will get 4x here and minus 1 from here is equal to 0. Now from this we can write x minus 9 is equal to 0 or 4x minus 1 is equal to 0, and from this we can find the solution as 4x is equal to 1, and dividing both sides by 4 we get x is equal to 1 over 4, which is the verified solution. As in the first method we verify that x is equal to 1 over 4 is a verified valid root of the given equation. Now from this we conclude that x is equal to 9, and as in the method number 1 we find only one valid root, which is x is equal to 1 over 4. So from this, uh, uh, as we already get x is equal to 1 over 4, so x is equal to 9 must not verify the given equation, and it will not be a valid root. So we will check the validity of this. For this we will take given equation again as, so this is the given equation, and clearly from this we can see that x is equal to 9 will not satisfy this given equation. If we put this value here, x is equal to 9, we will get 2 times 9 plus 5 square root of 9 is equal to 3, and on multiplying this we will get 18 plus 15 is equal to 3, that is 33 is equal to 3, which is not possible. Hence this root is also rejected and it is not a valid root. That's why we say that whenever a radical involved in the statement, that is uh, square root, so